Thanks to our show sponsors, Pests and Predators, the Soybean School, and Nutrien eKonomics. Looking for the best ag knowledge from top-notch industry experts? Join Mike Howell on Season 3 of The Dirt, an eKonomics podcast. From nutrient management to the latest weather, markets, and ag trends, The Dirt is your place for farm-smart topics to help boost your profitability. Dig in and listen to The Dirt on Apple Podcasts, Spotify, YouTube, or visit nutrien-economics.com.
Hello, everyone, and welcome to the Agronomists. Thank you so much for joining me. I am your host, Lyndsey Smith, and I know that there are probably a lot of other places you could be, maybe watching the hockey game, but you're here, and that's what matters. We've got a great show lined up for you tonight. As always, if you collect those CEU credits, head on over to realagriculture.com/agronomists tomorrow. Let us know you watch the show, and we'll get you all signed up for those. Let's get to it. Tonight, we're going to talk about grasshoppers, yes, but also plenty of other pests lurking in the crop canopy. We've got some maps, we've got some photos, and we've got two excellent guests. So let's bring them in. I've got with me James Tansey with the Saskatchewan Ministry of Agriculture and Tyler Wist with AAFC based at Saskatoon. Welcome here.
Hey there.
Hello.
Thank you for the welcome.
Yeah, so so Chris has mentioned that perhaps the second half of the show, we just stream the hockey game and we could be the commentary. I don't know. I don't know how I would do, you guys, but I'm wearing blue.
He shoots, he scores. Okay. He shoots, he scores.
Yeah, there you go. That's all we need. Okay. All right, let's start with James. We'll start with you. You were out in the field last week. It was cold. It was rainy. This week has warmed up significantly. What, as far as insect pests, are you seeing in the field right now?
So we are starting to get some reports of grasshopper damage. We had some initial deep concerns about grasshopper populations based on what we were seeing last year as part of the survey, an oviposition index that was developed by Ross Weiss with Ag Canada, and with very large numbers of eggs that we saw in the soil. Some of this is starting to materialize in the Southwest primarily, but we're also hearing reports from the central regions, Elbow and Rosetown, and I haven't heard reports from Alberta yet, but I know some of our neighbors south of the 49th are experiencing some grasshopper pressures as well.
Okay, we're going to talk a lot about that in a moment. But Tyler, I happen to follow you on Instagram, and
interesting.
And it's a fascinating follow. Everybody, do it. And you had what appeared to be a Ziploc bag full of flea beetles. Am I right on that one? What were you doing out there?
Yeah, that's one of our 8-pound sweep bags. And where did I get that from? Small little triangle of volunteer canola, now planted to wheat. And what was I collecting those for? We're trying to do oviposition assays with them. So that is, put some flea beetles in a cage to try to get them to lay eggs on things. And yeah, this is from a throwaway paper. Okay, a throwaway line in a paper that says, and we got them to lay eggs on black fabric. And so that's what we're trying.
So why does a research scientist want a flea beetle to lay eggs on black fabric or any other colored fabric for that matter?
That's a lovely question. So black fabric mimics soil. That's where they want to lay eggs. So you trick them. You say, hey, this looks like soil.
Come over here.
Maybe it's a good place to lay eggs. And then you get larvae. And then you try to create a colony of these flea beetles that you can do research with all year long. So we're not looking at this boom-bust cycle of, wow, there's a lot of flea beetles in the spring. And then, wow, there's a lot of flea beetles for a couple of weeks in the summer. And then they're gone. So we try to keep them around. So we're working on flea beetle colonies at AAFC.
So you're trying to be a flea beetle farmer is what you're trying to do.
That's a good way to put it.
Okay. I just imagine little tiny lassos to get them. Okay. Yeah, we'll work on that.
Honestly, that bag took me 5 seconds. So
so they weren't hard to catch.
They were crawling on those volunteer canolas,
Yeah.
That was in Saskatoon?
Yeah.
That was just outside Saskatoon, yeah.
So now flea beetles, of course, were one that last year we were very concerned about, didn't necessarily materialize in the way that we thought in many areas. This year, of
What
course, we
fields
do
were
have.
you in?
Well, I said in many areas, Tyler. I didn't say all of them.
Okay.
But this year, we know we've got reports of it all out of Alberta, where we actually have, as a treat producer, Sean tonight, cold temps. So the crop is not necessarily moving super quickly. James, what are you hearing on the flea beetle front in your area?
Primarily, we're hearing it from the north, primarily the northwest of Spiritwood area. So that corridor between Spiritwood and PA, and it's primarily striped, and that those populations been active for some time.
You got striped up there?
Yep,
I need them.
seems to be about the only place in the province where they're dominant. So they have been. It seems we've been experiencing a bit of a species composition shift, but they don't seem to like it. They don't seem to like it hot and dry. And of course, the last couple of years have been hot and dry.
Yeah.
Oh, yeah, a lot more spraying in southern Manitoba this year.
Yeah.
And
now,
oh, sorry, but I was just going to say. So, crucifer populations have been pretty spotty. So it sounds like there are a few hot spots. Sounds like near Saskatoon, but for the most part, not a big flea beetle year. It doesn't mean that growers shouldn't scout, because always scout, but primarily in the north is where we saw damage early, and of course once that crop gets to the 4-leaf stage, it's pretty resilient to flea beetle damage.
Don't forget, we're talking about two different species of flea beetles here. So we got striped flea beetle, we got crucifer flea beetle, and when they happen together, not good.
Bad things happen to good people. So James sort of does allude to perhaps having different areas with each of them, but they do, of course, happen in the same area. Which one do you tend, Tyler? Yeah, which one do you tend to see? Yeah, which one do you tend to see earlier?
It would be striped
flea beetle. Yeah, it comes out about 2 weeks earlier than the crucifer flea beetle. So let's say they get out of bed earlier in the springtime.
Okay.
So you plant your canola early thinking you're going to escape flea beetle pressure, and then the striped hit it. But the last few years haven't been conducive to striped flea beetle reproduction. It may be because we've got some money to study just the striped flea beetle that they disappeared for a little while. And so when I look at my graphs, we've got crucifer flea beetle just peaking and striped flea beetle just down here at the bottom. Okay.
Now, so Jason Vogt, who's out of Southern Manitoba, shares that it's been a wet and cool spring season, and that buteo is very highly water soluble, so dissipated quicker than when it's drier. That and cool conditions cause slow canola growth is sort of the thinking there. Now, we do know certainly that those flea beetles are the most destructive at that cotyledon stage. And James, as you alluded to, the faster that canola plant can get growing and get on to larger stages, the less we have to worry about them. So let's hope a return of some warm weather speeds this canola crop through, and it's only a few more days we really have to worry. But I think that's being a little presumptuous. I don't think that's going to happen. So get scouting. That's the key here for all of these pests. It'll just be different times that we're going to do so. So bringing it back. Ray's got a good question. Some comments from Swan River, Manitoba, that flea beetles were problematic, and suggestion was the pressure was worse for canola on soybean stubble as opposed to canola on cereal stubble. Any thoughts from the two of you? I know there's not a ton of soybeans in Saskatchewan, but Tyler, down in front.
Would you even have stubble from soybean? I mean, cereal stubble's going to be tall, right?
Thank you. Soybeans don't leave much behind. It's true.
Part of my project, we're looking at the effective stubble height on striped flea beetle pressure. Why? Well, if you're a striped flea beetle, you've got a surface layer of smell basically that's blowing out there, and if you've got a whole lot of stubble in the way, it might be protecting whatever is growing in that stubble from the flea beetles being able to detect it.
I like this, like a microclimate. That is
microclimates, exactly. Now, if you're a soybean plant, I don't think you're going to leave a lot of stubble behind, and so flea beetles love bare earth.
Okay, so that could be. Now, Jason disagrees in that he's not noticing a difference between stubble types. So that to me means we need to do more research. So if somebody could get on.
For Jason, I guess the question is he seeing a difference in weed species first thing in the spring?
Good question. Yeah. Yeah, because flea beetles are, I mean, they eat a whole host of plants, right? That they quite like.
No, they're the host range of striped is broader than crucifer, but they're both
Ah, interesting.
considered what's called oligophages. So they both primarily feed on the Brassicaceae.
Okay.
So yeah, cruciferous plants, they love them. They're
Okay.
both really attracted. So there's a breakdown product to one of the glucosinolates. The glucosinolate's
Yep.
called synagrin, and when it gets broken down by oh, I don't think that was me. It gets broken down by an enzyme called myrosinase, it cleaves the sugar group off it, and then what's left rearranges itself under different pH conditions. But one of the primary products is isothiocyanate, or ITC, and both of these species of flea beetles find that irresistible. And I think, Tyler, you're using those in your flea beetle traps, and they love it.
Interesting.
Yeah, isothiocyanate. Yeah,
Yeah, so
spicy. Jim,
very
what happened
spicy.
when
Yeah.
you spilled that in your lap?
It was pleasant. Yeah, no,
Oh no.
I had a close encounter with it when I was a summer student. So
Oh God.
when you eat wasabi or horseradish,
Yes. Yeah.
so that
That
really
burn.
strong sensation, that's
Yeah.
ITC. So
Okay.
I was working as a summer student trying to catch flea beetles, spilled some of this on myself, and holy Dinah.
Woo. Okay.
Yeah.
That's okay. Please don't do that again.
Oh, yeah, no,
And
I was very
maybe
careful with it now.
yeah, exactly. Okay, so let's focus on grasshoppers. We're probably going to spend a bit of time on this one. In that, certainly last year, even year before, as dry conditions, stretched out and incredibly dry in some areas, they were and potentially are going to be a huge issue. James, we've got a few different things to look at. So maybe let's start with, no, that's Sean is giving away our surprise guest tonight. Let's go to Sean, if you would, the
There's a
climate
weevil.
norm. There we go.
Oh,
This
yeah,
is the
okay,
climate norm. So let's go through what happened last year and why what happened last year informs this year.
Okay, so this is a model that was developed by Ross Weiss at Ag Canada, who's since retired, and unfortunately, I think we're going to feel his loss. He was a pretty good modeler, but this is what things look like normally for grasshopper oviposition. So this is the likelihood of grasshoppers ovipositing. This isn't actually going out and sampling eggs and measuring. It's a measure of the conditions that migratory grasshopper likes, and the other three pest species like things pretty similar. So I mean, there's going to be some differences, but overall they like these same sorts of temperature regimes in particular, and this is what we'd see normally.
Okay.
And so the Palliser triangle, of course, that's going to be characterized by moderate to heavy grasshopper pressure. And if you go to the next slide, this is
the last year averages. Wow.
Yeah, this is the model for last year. So according to the model and according to a lot of photos that I've seen sent to me by a number of people, a lot of eggs went into the soil. I had one picture in particular from Carolyn Siemens from SEIC, Saskatchewan Crop Insurance. And it looked like, I'm guessing, 500 to 600, if not more, eggs per square meter. Just massive populations of eggs. So, so there a lot of eggs went into the soil, and of course, eggs make babies, and we're just starting to see those nymphs hatch now. So.
Okay, so Lara de Mozak, hi Lara, thanks for joining us. A few weeks ago, had a report of hoppers on lentils on the eastern side of Alberta. So here's where we have to pause for a moment. So that is egg laying. Now, when we look at egg laying, we're talking about all species of egg laying. Like, we're not discerning species that are laying eggs at that point, because we have pest and non-pest species. So how do I know that grasshoppers laying eggs are pest species laying eggs, or is it really just a relative curve?
So what this model is built on is knowledge associated with migratory grasshopper, which is one of our primary pest species. So historically, that one's been, the great big one. So outbreaks in the 1940s, 1930s, up until 1960s, dominated by migratory grasshopper. We do have three other pest species. Right. They also overwinter as eggs. And so those include the two-striped grasshopper, Packard's grasshopper, and clearwing. And they also overwinter as eggs, so we're looking at similarities with those. We have a number of grasshopper species that overwinter as nymphs. We have some that overwinter as adults. Those ones are not typically pest species. So the ones we're concerned about all overwinter as eggs.
So Tyler, when Lara says that she saw a hopper a couple weeks ago, is it possible that was not a pest species? Is it likely it wasn't a pest species if it's that early in the season?
So if we were looking at an adult, i.e. you have wings, then no, that's not one of our pest species. Can it still cause damage? Potentially. Lentils, though, is most sensitive when it starts to flower. And that's when the hoppers like to clip the flowers off. No flowers, no pods, no seeds, no yield.
Sure.
So how early was early?
That's
Because
a good question. Yeah.
Yeah, we were getting reports of in rangelands, slant-faced grasshoppers being up as early as mid-March. And some of these can be damaging. They can occur at numbers, in excess of 60 per square meter, and can be damaging to rangeland. Not typically pests of crops, though. They tend to like sedges and rangeland grasses. But some of these actually have biennial life cycles, where you're going to get simultaneous emergence of the neonates, those first instar nymphs, and adults. And we got reports of both in March. Relatively limited sites, but pretty heavy densities of these slant-faced grasshoppers in some rangeland.
So in looking at that map, and maybe producer Sean, you can bring it back up, the actual egg counts from last year. That of course
they're not
is
counts.
It's
the
modeling.
Model.
Sorry, let's be clear. The modeling based on all sorts of factors, I'm sure. Now this modeling, of course, that gives us a degree of, where to be on the lookout, where conditions were conducive to such things. But what then? So here we are, almost end of June. We went through a whole winter. We have to go through spring. So let's say this was accurate going in. It's a good model. What sort of makes this map start to match up with actual infestations? What conditions work best for grasshoppers?
It's all about degree day accumulation. So there was some work that was done in the late 80s, and it determined that for migratory grasshopper, and that's the model that this is made on, needs 100 degree days base 10. So 100, 10 degrees Celsius is a bit of a magic temperature for grasshopper development. So 100 growing degree days base 10 for hatch to begin. And so we've just crossed that in the southern part of the province. We had a big band from Saskatchewan stretching down to Regina. For some time, we've crossed it now, but we just couldn't break 90 with it being so cool. So we've crossed that threshold for grasshopper development, and we're starting to see the emergence. So they don't all emerge at the same time. So we're going to get this peak in emergence associated with those populations, and then they'll trail off, and that emergence can continue for weeks. Functionally, we're just seeing the beginning of populations, and of course, the longer they spend in the soil, the more bad things can happen to nice little grasshoppers, right? So predators can happen. I haven't seen any evidence that moist conditions can be detrimental to grasshopper eggs, like very dry conditions can be. But once they do hatch and they experience those moist conditions, of course, they get exposed to fungal pathogens and other issues that can limit their population. So we're hoping with a continued moist trend and diminishing populations of grasshoppers as they get sick.
So Tyler, that and last week, and we've got a wheat school up at wheatschool.com right now about looking at grasshopper thresholds and populations. And so Tyler, to that point, with a return, thankfully, of some decent moisture in many areas, is that going to be enough, I guess, to say, grasshoppers won't be an issue? Or have these years of dry weather really set us up for it could still be a very significant issue for this year?
I'll get out my crystal ball here and let's see.
Okay, perfect. Thank you. Yeah.
Now, in my sweep samples, we've been getting nymphal grasshoppers, and so they're there. And right, you get enough puddles and they'll drown. But like Jim said too, the fungal pathogen can get going in their populations and knock them down. This is the spring we've been hoping for grasshoppers. So I think if we had a hot, dry spring, we'd be talking about a lot more damage already.
Oh yeah.
And so I think we might be getting saved by this cooler, wetter spring right now. So the grasshoppers don't like it hot and dry. Has it stopped them? Jim, you've been out there.
Yeah.
Taking some sweeps.
I think I know it's almost July, but it's still a little early, just because of degree day accumulation, because it's been so cool. But again, the longer that they take to get through their life cycle, the more bad things can happen to them. So.
Okay.
True that.
Yeah. Before we move on, and we're going to play a clip, and we're get into several other different pest species that we're going to have to talk about. We do have producer Sean, if you would. There's a very cool picture I want to show of the grasshopper eggs. If we could, it's a super cool picture. So I want to share this. Tyler, while we're looking at this is so cool.
Yeah.
This is courtesy Dan Johnson. He takes wonderful pictures. So.
That is terrifying, but beautiful all at once. Tyler, what?
Well, they're very small, though. Very small.
True. I could.
You don't have to be afraid of them.
Okay. Okay, but what does predate, or do we have parasitoids for grasshoppers? What eats grasshoppers?
So at this point,
otherwise. Yeah.
These eggs are going to be a tasty, tasty snack for things like blister beetle larvae and bee fly larvae. And they will find the adults will find these grasshopper egg beds, and they will lay their own eggs there. And they hatch into these predaceous larvae that go after these delicious looking eggs that you see in front of you.
Delicious. That's right. That's what that looks like. It is a super cool picture.
In these grasshopper outbreaks, we get these amazing, they're in the genus Epicota blister beetles. So we got the black blister beetles, the ash gray blister beetles, and also the golden blister beetles. And they boom when these grasshopper populations boom, because their larvae are just bellied up to that smorgasbord of grasshopper eggs. And then we get these cute little fuzzy bee flies that come out, and we get so many adults of them. And they're amazing pollinators because they've got these huge long hairs all over them. And their larvae have been bellied up to that same smorgasbord, eating these delicious looking grasshopper eggs, and their populations boom. And maybe even crickets as well. And I've said it before, and I'll say it again, though. Don't turn your back on an omnivore. I've said, those crickets, they're grasshopper egg predators. But, when the grasshopper eggs run out, the generalist kicks in, and then they're up on your canola, and they're feeding on your pods.
No, we certainly had lots of reports of field crickets last year, both in the spring and in the fall. So big hatch events. So some hatch events were actually frightening for some. Field crickets can certainly be an issue. And as far as bee fly, I've heard accounts of them hovering over these egg beds and actually flicking their eggs in.
Whoa!
In
Did you
flight.
get a video?
So I've never witnessed it myself. I've only heard accounts. So
So in the last grasshopper outbreak, I was actually doing field research, and these bee flies were an amazing pollinator of the flowers that I was working on. And there were so many of them that their behavior changed. Like, you can't get up close and personal with a bee fly, but I was able to get up and pet them. And it changed their behavior so much because there were so many of them. It was like they were in a feeding frenzy mode, and they weren't skittish anymore. They said, this is my nectar and I'm going to eat it. This is my pollen and I'm going to eat it. And there were 12, 13, 14, 20 in some cases, bee flies on these little flowers. And it was because of this big grasshopper outbreak. And we had so many two-striped grasshoppers that they were eating the tape that I was using to tag my pollination events off of the plants. They were eating tape. There were so many grasshoppers.
There's just so many.
No.
Now,
So if I could
envision
add,
you. Yeah, go ahead.
if I could
Jump
just add
in.
too, is I mean the pest species of grasshoppers that we have are native to this part of the
Right.
world. So they've seen it all, they've done it all, and they have a long coevolutionary history with a lot of different natural enemies.
Right.
So this is I mentioned before
That's
the
not one of
slant-faced
them.
grasshoppers. No, that's not one of them. That's one of the slant-faced grasshoppers. So
Okay.
that is that's a nymph of a clearwing.
Okay.
That is a
This
nymph of a
one.
packards.
Yeah, I
Cute.
learned. I didn't know that
Look
that
at all
was
So
those
one.
little
this
spots on his
yeah.
eye.
But the
Yeah.
so I mean a lot of invertebrates and vertebrates and worms and fungi and bacteria and viruses treat grasshoppers like a buffet, and so they are food and hosts for a number of different critters.
Right, which is very different than, of course, some of the other species that have been introduced relatively recently, those sorts of things, right? So now, so Jason's got a question. Summit disease Okay, so Jason said, is there any idea if all
Oh
the wet
yeah.
conditions, yes, in southern Manitoba may have caused summit disease fungus to affect them? So first off, Tyler, if you want to take this one, what is summit disease fungus? Is that actually its name? I know I've heard it called a couple different things.
Yeah.
And how does it affect them?
Well, so we're talking about
Okay.
a fungus known as Entomoptera grillii.
Ooh.
And so this fungus affects the grasshoppers and it makes them climb up to the top of the plants. And so I think, what does it do there, Jim? It affects their thermoregulation, and they say, I want to cool down, I'm going to go up to the top of the plant, or do I want to get hotter, I want to go bask?
They want to they want to get hotter. It's a behavioral it's called behavioral fever.
Right,
So
because damn, I'm sick, I'm going to burn it off like a fever.
it's usually associated with Bovaria bassiana, not with Entomoptera, where they'll engage in this basking behavior and get their internal temperature up into the high 30s, low 40s to limit the growth of that fungus. And so we do it physiologically, right? You know, you get sick, you get a fever. Yeah, your body kind of takes care of the temperature regulation. They have to do it behaviorally. Sorry, you were saying.
Okay, but then they go up there, but then they die up there?
They climb up there and they grab on tight and they die, right? And then, so why is it called summit disease? Because they just went to the top of the tallest plant out there. And then they wave back and forth and they disperse spores onto their brothers and sisters and cousins and relatives, and then they all get sick. And
so being a fungus, it likes moisture. So that's Jason's question.
Moisture. Yes.
So we may see more of that with the return of wet conditions. I have been told Florida did score. Okay. I want to just shift gears a bit. Yeah. So there you go. I am the bearer of bad news.
Way to bring the sadness there.
Yeah, sorry. Okay, we're going to go to a clip now. This is a Pulse School from this spring talking about pea leaf weevil, and it does bring in. We've got several different weevils to talk about. So this is Jay Beyer from Grow and Amber Bell in the latest Pulse School. So producer Sean, if you would.
Time of this stage of the crop, it's an ideal time to go look for pea leaf weevil. You're going to look for little notches in the leaves. While that's some damage, it's not a big deal. The main impact of pea leaf weevil is when they lay all their eggs, and then the eggs drop, they become larvae. They go into the nodules of the rhizobia that are on the pea leaf weevil, the nitrogen fixing bacteria, and they eat those up, and then they cause damage to them, reduce the yield, and reduce the nitrogen fixation. So that's where the major damage is, but the ideal time to look is right now with the 2-3 leaf stage, and you can see how many notches you have on what they call the clamshell leaf, the initial leaf that comes out. If you see at least one notch in more than 30% of those clamshell leaves, then you have to consider immediate control.
Okay, and so this is a perfect stage really to be looking for a lot of things in our crops. So you would recommend for sure that farmers just get out there and start looking at what you have on the
Absolutely. Right? Scouting is so critical. People have to get out there now that all the seeding is done. For a lot of people, they can't go fishing, they can't go away. They've got to go start checking their crops that have emerged like this one. This was seeded early May. And now it's time to start checking for insects.
Okay, so we've talked a little bit about the symptoms. Now, what impact does that have on yield, on like further on down in the season? What impact does the damage have?
If the damage is really severe to the rhizobia nodules, we've seen 30% reduction in yield for a crop. So with a heavy infestation of pea leaf weevil, there can be real significant damage further down. These little bits of bites that are taken off of the leaves really don't impact the production very much, but when it gets to that later stage, yes, you can have pretty significant yield drop. And this area is one which has a pretty significant population of pea leaf weevil.
And what constitutes a heavy damage or a heavy amount of pea leaf weevil?
Right. That damage, when we've been doing surveys with Shelley Barkley with Alberta Agriculture, we've seen leaves that have had 5 and 6 notches out of each and every individual leaf all the way up the stem. That's really significant.
Our sponsors tonight are the Soybean School, Nutrien eKonomics, and Pests and Predators. The Pests and Predators podcast series is where top entomologists highlight the insect field heroes hard at work for Canadian farmers. Hosted by Real Agriculture's Sean Haney and brought to you by Field Heroes, powered by the Western Grains Research Foundation, Pests and Predators is an in-depth look at the many insects who share our fields. Find out more at realagriculture.com, download the podcasts, or visit fieldheroes.ca.
And we're back, and Edmonton apparently has answered back already, and it is tied up at 1. So you're welcome for that for that update. Okay, so let's get going on some of these weevils. There are many. They are goodness, sometimes very difficult to deal with. Let's start with pea leaf weevil. It is perhaps a more minor pest, but certainly can be very damaging. James, is this one on the decline or building? Where are we at with pea leaf weevil in different areas?
Okay, just I guess a little bit of backstory. So the last couple of years, we've seen a substantial increase in the populations, both in the range and the density. So this animal's European, and it's a relatively recent arrival to the Western Canadian plains, and so it's invasive. So you mentioned before, insects that escape their natural predators. That's one of the thoughts that's happening here. It's called the enemy release hypothesis. So you release them from the control that they would have with their enemies. They tend to go to town. This one, however, is not terribly cold hardy. So it's somewhat limited by that, and there may be some other factors that are limiting their populations. So we quite literally in the last day or two finished our pea leaf weevil survey, and it really looks like numbers are down relative to last year, particularly in areas that didn't see much in the way of snowfall.
Right, so that would potentially significantly impact their ability to survive.
Yeah, no insulation, and they're exposed to really cold ambient temperatures. And they just don't have the wherewithal to survive that. So
okay,
yeah,
so
a lot of Saskatchewan had a brown Christmas.
Yeah. So that
and a really heavy cold snap with not much snow. So
see, the air hurting our face works in our favor sometimes. Okay,
That's right.
That's why we live where the air hurts our face.
Yes.
Lara shares have seen pea leaf weevil damage mid-May in alfalfa, but didn't see the actual insect. No other pulses around in the Didsbury area. So it's not native. Does it like other crops other than peas? It's a good question.
So it may not have been pea leaf weevil. We have several other weevil species. Ones that like clover. 5.
Okay.
Oh, way to put a number on it. Love that quantification. Right?
5
so
others. Okay.
Sweet clover weevil. That's one that'll cause notching. So they'll go after alfalfa, sweet clover, and you'll see those notches on things before you see it on peas. Okay. So can we tell the difference, Jim, between a pea leaf weevil and a sweet clover weevil feeding damage?
At first glance, they are difficult to tell apart, and it's important to note that field pea and faba are what are considered true hosts of pea leaf weevil. So that is their reproductive hosts. The larvae can develop on them, but the adults will happily munch on a whole variety of different legumes.
Yeah. So and that, I guess, that's a key difference, is that the real economic damage happens when the larvae feed on the rhizobia, on the nodules, and interfere with end fixation, right? Like the actual notching isn't going to make a huge yield impact necessarily.
Not typically. You would need pretty heavy foliar damage from the adults to cause that. But yeah, where the notching is important is it's an indicator of what you're looking at for larval pressure. So usually we look at a threshold of 30% of the clam leaves being damaged. So that is the terminal leaf. The rub on that is the application of foliar insecticides hasn't been demonstrated to be all that efficacious for improving yields. So you have a nominal threshold, but no real recourse. So,
and do we have seed treatments that can offer any protection to the root, or it's too long after?
Oh no, absolutely. Yep.
Yeah, we do. Okay. Tyler,
my compatriot Megan Vankowski showed that seed treatments are efficacious, but what Jim is quoting there is Megan's research also saying that spraying not very efficacious.
So you have to be planning ahead.
Yeah, so that's Megan and Hector. That was Megan's master's project, really.
Yeah, cool. Yeah. Alara says, so notching does not automatically mean pea leaf weevil, and this is why she tunes in. And
sorry, Lara.
We love it. No,
you're welcome,
we're all
Larry.
learning
now
together.
We're in
You're
something
welcome.
new on the Agronomists.
Exactly. I did as well, which is fantastic. Okay, so now, producer Sean, if you would bring up another weevil. This is a fantastic image. I can always count on the entomologist to send in some really great photos. And so we have a cabbage seed pod weevil. And so this, if I'm not mistaken, is a canola pest. Mm-hmm. This is a beautiful image, but I will tell you that snout does set me off a little as far as what damage this pest does. So James, we'll start with you. What are we seeing with cabbage seed pod weevil? It is a bit early, for sure.
It is a bit early, but we are seeing a lot of activity, primarily in the Southwest.
Right now.
Pardon me?
I have one in a cage right now. You said early activity. I have one.
Yeah. Okay. So there you go.
Yeah. And quite numerous. It sounds like from the account that I heard today, dozens per sweep. So when you get to early to mid flower, I mean that's the time to be scouting your canola. It's a little bit early for that, but I think I think it's important for growers to be scouting for this one and probably scouting early. So the adults, they can cause direct damage. They can cause bud blasts through direct feeding. They can also damage the developing pods, but the bulk of the damage from this one is from egg laying inside those developing pods. So what she's going to do, she's going to go find a developing pod, chew a little hole in it with that rostrum, so she's got, regular insect mouth parts on the end of that snout, and she's going to, chewing mouth parts. She's going to chew a little hole in there. She's going to turn around, lay a single egg in there, and deposit what's called an oviposition deterring pheromone. And the reason that she's doing that, she's labeling that pod so that other females don't show up and lay their eggs into it, because they're very competitive. Yeah, there can be only one. So for all you 80s movies fan,
Highlander reference. Yeah. Well done.
But they'll happily cannibalize each other if they encounter each other in that pod.
Wow. Okay.
So I mean, obviously the pod size is really important when it comes to host choice for these guys. So those developing larvae are going to consume the seeds, and that entry point for the egg and the exit point when that larva completes development and falls to the soil to pupate, both of those can be avenues for pathogens. So I mean, bit of a triple threat as far as that goes. But it seems these ones like conditions that are conducive to good canola crops, and with historic this is another invasive. And with historic populations being pretty heavy in the Southwest, I mean, we're seeing those populations apparently really ramping up right now. So we're looking at starting our survey for this one probably as early as next week, early the following week. All depends on the stage of the canola, but it sounds like the weevils are up already. So.
And so this is when you would sweep for and count what you find in your sweep net?
Yeah, and it depends on crop conditions. So if the crop condition's relatively poor, then your tolerance is going to be lower. So then you're looking at 2.5 per sweep. You want to do at least 10 sweeps. You want best to do, the more sweeps you get, the more areas of your crop, the more representative it is. If the crop's in good shape and if the growing conditions are good and the crop is healthy, then you can tolerate 4 per sweep and save some money. A question that I got from a grower a couple of days ago is they're growing yellow mustard. So that is Sinapis alba. And yellow mustard is actually resistant to cabbage seed pod weevil. So the pod size is all wrong. So the girls, they the pod's hairy and it's the wrong size, and so the girls tend to not like that one very much, and the glucosinolate profile is all wrong. So chemically, it's pretty well defended, and morphologically, it doesn't hit that sweet spot. So it is resistant. So there are no thresholds in yellow mustard. But brown mustard or oriental mustard, you consider the thresholds comparable for canola.
I feel like we'd solve a lot of problems if we could get this hairy canola thing to happen. But for some reason, it's taking a while. So if we could get on that. Anyway, I'm trying to solve some problems here. Tyler, this is not a native pest, this cabbage seed pod weevil. Do we have anything do we just have to depend on generalists, or do we have anything that seems to like this pest, or is it on its own?
Ooh, there's some parasitoids that'll go after the cabbage seed pod weevil. Oh, yeah. So, I mean, when you're an insect, there's always something out there trying to sting you and lay eggs in you. And
it's terrifying.
Yeah, same thing for that cabbage seed pod weevil.
Okay.
Yeah, so there's one in particular called Nutrien tedius, and my PhD advisor Lloyd Dosdall, who sadly passed away, but that was one of his last efforts, was to look at the parasitoid complex of these animals, and they seem to be increasing slowly. By into the early late 1990s, early 2000s, or into the mid 2000s, really. But that work hasn't really continued since. So we don't really know the status of the parasitoids right now.
Mm-hmm. Okay. So as we talked about with the grasshoppers, so many things co-evolving with it over time. We hope that things like this do evolve alongside, but nature is a bit behind and has to try and catch up when something's introduced like this.
We usually try to cheat and go back to its home range. Right. So if it's the European
find something
problem, find something. It'll go through probably 10 years of screening before it's ever released here.
Very
to make sure that
very
rigorous testing, and then it'll be released here in hopes that it becomes established and limits the populations of the pest.
Because we don't want to be like Australia and just bring in things we think might work, and then they just become another problem, right?
Yeah.
Are you talking about licking cane toads? Is that what you're talking about?
Something like
or
that.
Myxovirus, or the Australians have actually done some really superb work on biological control
because they learned.
So I mean, we've got one really good example of a leaf chewer that occurs on wheat, the cereal leaf beetle, and it is really well controlled by a parasitoid. So it's another European, it was reintroduced to its natural enemy, and the natural enemy does a heck of a job of limiting its populations.
Yeah, knocks it right back. Poor Haley says, I can't find any cereal leaf beetle fields to sting it.
Yeah, so, a bad day for an entomologist is a very different bad day for other people. I got to tell you.
Good way to put it.
Yeah, exactly. Okay, let's just pause for a moment as we reach sort of the last segment of our show. We're going to have one last thank you to our show sponsors. Then we'll get to a couple threshold questions and a few other pests right after this.
Our sponsors tonight are Nutrien, eKonomics, Pests and Predators, and the Soybean School. The Soybean School on realagriculture.com is an agronomy and issues video series that allows soybean growers to learn on their own time and at their own pace in order to become better growers in the long term, thus improving the overall health of soybean production in Canada. The Soybean School is made possible by support from Syngenta Canada and BASF.
So what do we call that nose on the weevil? What is that actually called?
Rostrum.
The rostrum. I call it the gonzo nose.
That works
that's
too.
Just what I call it.
Yeah.
So
Yeah, it's not
okay.
actually their nose though. So they actually
Well,
they
I
smell
know,
it.
but that's what it looks like to me.
Yeah, no,
But
they actually smell.
that
Yeah,
blows
they
my
do look
mind that
like
there's
gonzo.
mouth
Yeah.
parts at the end. Like
I think
that's
I
wild
think
to
they're
me.
cute. I know they're a pest, but I think they're cute. So
And well, um, entomologists, I gotta tell you. Okay, there's a few other things I want to touch base on, and certainly to talk about, as you mentioned, James and Tyler will talk about some of the things that you're looking at as well. Scouting, of course, is super important, as is monitoring, and that is one of the things that we've talked about. So, in looking forward, either what's gone out or what's about to go out, Tyler, maybe I'll start with you. Where are we at with wheat midge? Are we trapping? Are we looking? Where's that at?
So today's the day where we deployed probably 150 wheat midge pheromone traps across Western Canada.
Ooh,
So
nice.
looking
Yep.
forward to data pouring in on Thursday, and thanks very much to everyone participating in the Midge Busters project. I myself, we put up at least 3 traps today. Should have been more like 6 or 7, but yeah, we got to collaborate with the U of S and get in there. But why are we caring about wheat midge this year? Well, we've been talking about cool, wet conditions, and those wet conditions bring out the wheat midge. So we've had, at least in my area, way more than enough rain to get those wheat midge larvae to start coming out of the ground. Heat units are important, but the ground warms up pretty handily when the sun hits it. So so today is the 24th of June, 2024. And we're hoping to get a few zeros before we get into the next collection date. So likely honestly, I've had traps up for the last week because I've been curious. And I haven't caught a single wheat midge yet. Nothing so far, yeah. Okay. So a couple of field sites. And this year I'm planting a lot of wheat. So mostly it's because I have a lot of weed problems from last year, but
at least you're being honest.
I'm hoping for a wheat midge year that I'll be able to study wheat midge in little segments of wheat. So we have a few different varieties on the go. And from what I've been hearing, we've got cereal aphids building up in Nebraska, which makes me excited for a cereal aphid year up here.
Okay, so do cereal aphids travel? Do they
cereal aphids? Yeah. So I'm sitting in a wheat field and it's starting to turn yellow and senesce. I'm going to get wings and leave. So that's what the cereal aphids do. And they catch a ride on the winds and they come up to greener pastures up here, where in more northerly climates, the wheat is greener than it was down south. And so they move up. Yeah. And they use a lot of these low-level jet streams to travel. So I'll think back to 2015. We had this big thunderstorm system that just traveled south to north in Saskatchewan. And after that had finished going across the prairies, we could see aphids left behind all the way through.
Really?
And so, so this is they like to kind of travel along with it, and the fronts bring them down into the fields.
Right.
So I know that was a terrible explanation, but
no, okay, no, this is
to explain jet streams.
I think those of us who follow weather apps rather closely, we think about these things a lot. And you watch these big systems, of course, start from down south and move an incredible amount of distance. James, how important then for some insects, so cereal aphid, what other ones blow in? I know there's a few canola ones we have to worry about too.
Well, some of them you're probably referring to diamondback moth, and that
they're
one
here.
They're here, and they're here pretty early, and there is we're still looking at it, but there may be some concern that they're overwintering here and maybe in some numbers. But typically those ones are going to move great distances. So they're they're leaving from Texas, northern Mexico, northern Florida, and exactly what stimulates them to take flight is it's suspected that it has to do with senescence of their host plants there and harvest. So there'll be major pests of vegetable production in those parts of the world. Those crops get harvested. Diamondback take flight in big numbers, and then they're like Tyler mentioned, they're going to cruise along at those high altitude wind streams. So they follow the warm air, typically 300-500 meters, but they can get as high as 4 kilometers. So they can move at great heights. It's considered passive migration. I mean, they're little farts of moths, so they're
along for the ride. Yeah,
but they can get pushed 1,000 kilometers a day on these winds. Wow. So they're not spending that much time in the air currents. And what exactly causes them to rain down on a particular area, I don't think is well understood. Do you know, Tyler?
Right.
I don't think it's well understood with them. Yeah. Aphids, I think the fronts in front of those big thunderstorms,
like when the pressure changes,
like we had yesterday.
Yeah, but you'll see them, just drop out of the air column en masse, in either the Northern Great Plains in the States or in the Prairie provinces, all the way up to the Yukon. So
it's possible that their airstream just got a little too cold for them, and down they come, possible too. And then out they fall. Yeah. Right, another migratory pest, aster leafhoppers, and so I was really sad on my birthday this year because the leafhoppers didn't show up, and then here we are out in my alfalfa field. I got my grad student Tyler. Yes, his name is also Tyler. We call him Junior Tyler. And I said, well, let's go sweep, see if we can find some aphids for your project. And he's like, oh, there's leafhoppers in here. And I said, can't be aster leafhoppers. Sure enough. June the 7th, we had the aster leafhoppers, but about a month before that, we had heard reports of leafhoppers in the states bordering Canada. And I said, well, they didn't make it all the way up here. And then, I'm sad. They didn't come up here. But so what I think we're seeing this year is maybe a 3-step migration. So they showed up in these northern states, and they had their second generation of flea beetles on their big first migration. They came up that far. Actually, they probably came up into Nebraska, Kansas on the winter wheat, and then boom, they came up again. And now we're hitting this last leg of their migration up into Saskatchewan. And it was just at about the right time that they would have been producing adults out of, say, Minnesota, North Dakota, South Dakota. And we had one day where the winds were right, and here they are.
So but that doesn't.
With these ones,
I was going to say, does that mean? Right? But does that mean it's an aster yellows year? Because it feels to me like it's so random. It doesn't always mean that it's an aster yellows year. It's not. Yeah. It's not random. Why is it not random? Because I've been studying it for a few years now. So if it's not, then how do we get it? When does it happen?
So what I'm tying the aster yellows outbreak years to 2012, 2023, last year was actually an aster yellows outbreak year, is drought in Kansas, Nebraska, in that winter wheat region. So if you're a leafhopper and you're feeding on a wheat plant and your wheat plant is just dying because there's not enough moisture, you're going to move on to another host. So these things, they love the cereals, but they'll happily feed on over 300 different plants. They move on to your weedy reservoir hosts, and I say reservoir because these hosts are hosting aster yellows. They pick it up, and then, they catch the same wind currents, and they come up to Saskatchewan, Manitoba, into the northern part of Alberta last year, and they cause havoc when they get that. 2012, we had over 10% of the population that migrated infected. And in 2023, we had over 16% of the population. Those migrants were infected with aster yellows. So,
So, all right. So now you found some. So can you test them?
We can test them.
Okay, let us know. Keep us posted.
I will let you know. Sure.
We need to know these things.
Unfortunately, here's the trouble. My project has come to the end of its funding cycle.
Of course.
And I'm now working on my final project report. And so we worked it out. So for me to test one leafhopper properly costs about $15.
For one
Multiply that for one hopper, Now, we've developed a system to do it cheaper, But if I want scientific grade data, we want to do it properly, and we want to use the proper kits, and it works out to about $15 a leaf hopper.
Ouch.
So, yeah. So without the funding there, I don't have a lab to keep on testing the leaf hoppers. So,
somebody, okay.
James, what we're trying to do is pass off the cheap testing to the provincial laboratories so that they can get a better idea of whether these things are infected or not.
Okay, that might work.
Yeah,
we'll talk.
Okay.
Yeah, they might.
Have his people call your people. There you go.
Yeah, we'll do lunch.
Yeah.
I wanted to mention too is we got a bit of an early warning again from our colleagues just south of the border about pea aphid, and they are starting to show up in some numbers too. And Tyler, I think you're finding them in alfalfa, and of course they can be problematic in a number of different pulses. So
yeah, we found pea aphids. So when Junior Tyler was sweeping the alfalfa, he found pea aphids as well. But remarkably, what he found a few with wings, but he also found one or two of them that were adults without wings, which means that they had been there already for a good 8 days developing in the alfalfa into these individuals without wings. And so when you have an individual without wings, it means they're going to stay there and they're just going to keep having babies and reproducing. If we find none of them without wings, that means, hey, I just flew into this alfalfa and now I'm going to lay some babies and start a population. So what that actually probably told me,
no wings means they've actually been here a while. So if you're finding them with wings, it means they're new.
Yeah, they need wings to fly.
If they all have wings, then we can kind of look at that population and say, you just arrived and we just caught you. So you've just flown in, right? You're not going to flow in or fly in if you don't have wings. But if you're an adult, what's that?
You can walk, I guess. Yeah. Far.
That's a long way to walk from the States, isn't it?
Yeah.
Oh, yeah. For an aphid,
cross the border and flash their green card.
Yes, Red Bull to the wingless aphids.
Okay, yes, Red Bull. It gives you wings. Okay, so question though, it's called the pea aphid. I'm going to assume that it does attack peas, but as you mentioned, James, there are other hosts. So what other species, what other crop types does pea aphid actually do economic damage to potentially?
Oh yeah, a number of them. I mean, all of our pulse crops.
All the pulses, except maybe
all the pulses. Okay.
Yeah.
And so we're actually looking for people to help us out in our survey. I posted it on Twitter. Junior Tyler has put together an amazing survey. And basically it's a yes or a no. Oh, I was in my lentil field on June the 24th and I saw pea aphids. Yes. Boom. I was in a lentil field. Boom. Here's my location. Boom. And then we can start mapping it out and seeing how these things are moving about the province.
Okay. So that
which is the ultimate goal of that. Yeah.
Right.
Your homework is now you know. There's
everybody,
a survey.
Yes. The more you know.
Fill out the survey.
So this is one thing, though, that I do think is really important to mention. Of course, we've got the Field Heroes. We've got the Prairie Pest Monitoring Network. We've got the trap systems. Like there's a lot. All of this monitoring and all of this information gathering takes a team, and it takes a very large village all over Western Canada. So I did want to send a thank you, even though I don't know all these people, to everyone who does participate. But it is incredibly important that people do participate and host these traps and reports. So please, everyone, if you can, do, and agronomists as well. Yes, James, go ahead.
Yeah, if I can add too, we do actually have a sign up for surveys. So there, I don't have it handy, but if you do a Google search for Saskatchewan insect surveys, pardon me, there will be a QR code. Point your phone at it, little drop down menu, and you can sign up to participate in our surveys. So we actually need permission. We need permission to access lands. Right. So it's really, really important that people let us know that we can get in there.
And that'll get allowance for people to go into your fields, right? So. Yep. I'm trying to get around that by saying, hey, go into your own fields and then tell me about it.
That is also okay. We can do that too.
So Tyler's doing his surveys.
That's how Junior Tyler.
Tyler. And Senior Tyler. Senior Tyler is running hashtag Midgebusters. So check that out on, I guess it's X. I got to stop saying Twitter, right?
X.
And
I still call it Twitter.
so,
okay.
well, that's where we post it. But we've also got a WhatsApp group where we're sharing information, and I'm creating maps based on when they're coming out. So I will be pushing that on social media. If the wheat mids start coming out, you're going to hear about it, and I'll let you know. So this is what this is about, right?
That is,
it's about getting information into the hands of the growers.
Yep, as soon as possible, or maybe even early. Let's go early.
Yeah, and we'll be getting our map produced for pea leaf weevil relatively shortly. I don't want to say next week, but relatively shortly.
But like maybe next week. Okay.
No,
we'll walk for it.
Probably not next week. No.
James has got things to do. Okay, we'll watch for that as well. All right, we are out of time for tonight's show. Thank you everyone who did at least halfway watch the show. We know there's a lot of other stuff going on. This was a fascinating discussion and super fun as always. So thank you, James, and thank you, Tyler, for joining me here on The Agronomists. I really do appreciate it.
Hey, you're welcome,
all right.
Lyndsey.
Yes, and thank you
Jim.
Yes.
Thanks for doing most of the talking.
Nonsense. Thank you for sending in such great pictures. Some of them are terrifying, but most of them are fascinating. Thank you to our
Don't
sponsors.
Forget the rostrum.
Oh yes, the rostrum. The Gonzo knows. Yes. And we learned something, and that is the whole point. Okay. Thank you to Nutrien eKonomics. Thank you to the Soybean School, and thank you to the Pest and Predators podcast for sponsoring tonight's show. Next week is a holiday, so there will not be a show, but July 8th, we've got Tom Wolfe locked in, and I'm lining up a couple other cool guests. We'll see if I can convince Jason DeVoe to join as well. We're going to talk about spraying in challenging conditions. So that is July 8th, 8 p.m. Eastern. Join us, please. And everybody have a great week, and we'll see you soon here on The Agronomists. Cheers, everybody.